Okay, relative to the origin O, A and B respectively, A and B are non-zero vector. It is given that A cross B is 0 and find A dot B in terms of mod B. Okay, great. So this first part here, very important. I think I've done this recently. I'm not sure where. This case here, we are told that A cross B is a zero vector. In other words, right, A is equals to KB. In very, very important. Now this means, okay, maybe I shouldn't just, when this is zero vector means A is parallel to B, and from O level we know that this is A equals to KB. This is the first thing you should be able to tell, okay? Then find A dot B in terms of mod B. So A dot B would just be mod A mod B cosine theta. Okay. Now because they are parallel, so parallel meaning theta is 0 degrees. And then mod A is actually KB. This is mod B and this is cosine 0. And this will just be K mod B 1. This is K mod B square. Okay? That's how you show where K is a constant, where K is a constant. So I'm just going to try to explain. Now, if A cross B not equal to 0, meaning they are not parallel. So meaning this just tells you they are not parallel. So A is not parallel to B. Okay. Okay. So anyway, it's quite redundant actually. I feel it should be quite redundant one. Point P is a full perpendicular of A to the line OB. So if there's a A, there's a B. Part 2. Just draw it out. So this is O here. Then if this is A, OA and OB. I can't stress, I'm very stressed. He says, always draw when you're doing vectors question. Don't leave it to chance. So because drawing itself requires practice, okay? Don't try and save time by not drawing. You inadvertently you will waste more time when you don't draw, okay? Unless you are good like you practice like very well already, you can get 9 or 10 marks, then by all means. Okay, point P is a full perpendicular from A, so in other words, you draw this out. This would be point P here, 90 degrees P. Okay, then to the line OB, and the Q is the full perpendicular of B to line OA. So this is Q. Here is Q. And this one here. And this go a bit. Q is here. Okay. Write down the length of AP and BQ. Oh, that is not too bad. AP is this one here. This opposite length here. Okay. So you have A and B. So this is A. This is B. Remember, this is B. If you want the opposite length, the angle is here because you have the angle between them. So this is A cross B unit vector. Okay, this is A cross B unit vector. The sign opposite will be sine. Sine will correspond to cross. So the cross product is a magic triangle cross product. Unit vector the B. Don't unit vector the hypotenuse. So in this case here, this is a hypotenuse. OA is a hypotenuse. So length AP would just be mod A cross with B unit vector. So this is A cross B over mod B. Okay, that is AP. Then you have got Q is the full perpendicular from B. Find O to the line OA. Write down BQ. So BQ is here. This one here. So same thing, magic triangle. This will be cross product. Here, cross product. So this is A cross B. This time round, you see this is where it's also cross opposite. This will be the hypo now. So don't unit vector the hypo, you unit vector the adjacent side. That's why I'm very adamant about it. When I say you unit vector, don't unit vector the hypo. So if you're confused which one to unit vector, just don't unit vector the hypo. Okay? Hypo, you must preserve the length of the hypo. That's why the hypo is important. the BQ is equals to mod V cross A unit vector, which is actually A cross V over mod A. That is quite okay, I think. Okay, just draw it out. You should be able to do it. You can only use this for information. Actually, this statement, I feel that this one should be placed before this hence. So anyway, you shouldn't use this information for this part here. Okay. Very likely no lah. I think the way they phrase the question is a bit off. This one here, I think likely in A level, what's gonna happen is, I understand what I'm trying to say. Totally understand. This one should be before this hence here. They shouldn't put here because some students may think that can use this information for this one. Yeah, so it's a bit vague. I agree, but you shouldn't use that information for the write down one. Let's hence show that mod A equals to mod B. So if mod A, so AP equals to BQ, you just need to equate both of these lah. So since AP equals to BQ, so very simply just put mod AB cross B equals to mod B equals to mod A cross B over mod A. Now these are all the same values here. These two are the same values. So you can actually cancel this out. Life is good. Easy job. These are scalar values. And cancel this out. This will be 1 over mod B. This is 1 over mod A. Then A equals to mod B. 1 mark. Quite okay, I think. Okay, anyway. Alright, so for part 3, given that the angle between A and B is phi radians, show that A dot B is minus mod A squared cosine 2 theta. Okay, great. So how to do? Now, first thing first, we try and understand how to decide what is this phi here. Like, okay, we even use dot product. When you use your dot product and you use this angle here, you should A dot, okay, the first thing you must establish is when you want to use dot product, this should be mod A minus B cosine phi. Any issue there? When you take these two vectors, dot it, right? The angle here should be the angle between the two vectors, whatever vector it may be lah. Okay, so this is the equation. This looks damn annoying, right? This is annoying like heck. Like, what's going on, man? Life is tough. This one is tough. So we are told to show A dot B lah. Of course, we don't want. I don't think we need A dot A minus B. But what I'm saying, if you want to use phi for the dot product, it should be this. This should be the correct one. But I don't think you should do this. So what should you do? You should draw out your triangle. Okay. Don't think so much, one. Just draw it out. So A is what? A is OA, right? Correct. Then A minus B is what? A minus B is BA. Right? BA. BA is A minus B, ma. Correct? So phi is what? Phi is the angle between BA. So if you were to think about it, draw it out. Draw the triangle out. Don't think so much, man. Just draw it out first. Like, always draw, okay? Draw. You don't understand what's going on. If you don't draw, you wouldn't know. So I'm going to just draw this out first. I'm going to draw this out. So this is O. This is A. Then this is B. So B to A and O to A. This here and this. If I use angle between OA and B to A. Okay. This is OA. This is BA here. OA, BA here. The angle between them is phi. So this is phi lor. If this is phi also. BA ma, BA this direction, this is OA. Then A to B. Okay, so this is A, right? So this case here, this is A. Then this is B. Right? Okay, great. So what to do next? What you do is, once you do the drawing already, the next thing is try and solve it geometrically, because you see this mod A equals mod B here. This is a goal, man. This is a goal mine, because if I draw this triangle out, mod A equals mod B, instantaneously I know this is a isosceles triangle. Because the length are the same. the length are the same, since a triangle OAB is an isosceles triangle. Since mod A equals to mod B. Shook. This is damn shook. This one would make life so much easier for us. Life is good. We can yeah. This is phi, then we straight away can deduce our very pro one from secondary school. We know this is phi. Of course, this is phi. Then this angle here very strictly is actually 2 pi minus 2 phi. Rubbish. It's pi minus 2 phi. Okay, 180. Pi is 180 ma, so this angle is pi minus 2 phi. You get this already. You straight away can just do a dot b. So a dot b, when you use a dot b, I'm not sure. Okay, so this pi. So hence angle AOB is pi minus 2 pi angle sum. Angle sum of triangle. Okay, so this case here, so this will give us a dot. When you use a dot b, you need to use the angle between a and b. So angle b and b is pi minus 2 phi. So this is mod a, mod b cosine 2 pi minus pi minus 2 phi. Pi minus 2 phi. Okay, I think that's about it. We need this in mod A, and then we are very happy we got our cosine 2 phi. Wow, happy. This is good, man. This is so cosine pi minus 2 phi would be in the second quadrant. So you'll be, did they say pi? Oh, is pi radian, angle pi radian 2 pi. Yeah, so great. This will be negative 2 pi cosine 2 pi. But if you do not know what is it, you can just use the formula. Okay. Anyway, mod A is equals to mod B, so this will be mod A square. Then this, if you're not too sure, if you've forgotten that this is this formula here, okay, you can use this formula to deduce. Okay, what I'm doing here is I'm thinking in terms of quadrant 1, quadrant 2. That's why I know this is negative. But if you don't, you can just use cosine A minus B is equal to cosine A cosine B plus sine A sine B. Okay, you just use this formula. You still get the same, but it's just a lengthier process. This is 180 minus an angle. So 180 minus an angle, this is in quadrant 2. Okay, so whatever happens here, you change to the first quadrant, it will be negative. Okay, let's say if this is in quadrant 1, then this will be in quadrant 2. So that's why it's like that. So this is negative. But if you are not too sure, like I said, you can just use this formula here. So cosine pi minus 2 phi is equals to cosine pi cosine 2 phi plus sine pi sine 2 phi. This is negative cosine 2 phi plus 0. Yeah. Okay. So that's it. Shown. Just like that. Yeah. What I would suggest is you find the height, right? Then you use the unit vector plus minus top bottom. Okay, so this case here, the pyramid ORST has a triangular base of ORS, right? You draw this out ORS like that. This is ORS. Wow, ORS is here. ORST. ORS. This is the base, is it? Triangular base here. The height OT. The height OT, I'm not sure where is it at. So ORST. I think this one OT, they should write perpendicular height. But anyway, they did not write. It's okay. I'm just going to assume that it's perpendicular height here. because it may not show that it's like, okay, this is 90 degrees here. Okay, so we know that we need to find this height here, not an issue. Okay, but this normal vector here, you need to find later we need to find out what's the normal vector here. The normal vector pointing upward of ORS. So you need this normal vector here, which is this normal here is actually OR cross with OS. Correct? The normal of this plane here, important. So this normal here. Okay, so go back to our pyramid here. You have this pyramid here. This is a tetrahedron. I'm not sure whether you can see this base here. So this tetrahedron looks like that. Yeah. So it looks like that. Like that. Okay. So where this is, let me just put this as a fainter blue. Maybe I just do this like that. So this is like ORS. This is 90, 90, then this is T here. Now, of course, this T is not the only position you can have, because now you're dealing with three-dimensional form. You can also have a T below here, right? So T2 here, because the T can be on top or below. That's why there are two position vectors here. So your natural sensing is always go and find what is the height here, the height here. Okay, this is the height. The height, which is the OT, find the length of OT. Okay, then if you want to find T, right? So OT, right? Whatever units here, let's say, I don't know what's the height here. So it will be height plus minus unit vector multiplied with the unit vector. Okay, the height here multiplied by unit vector. Because you just, the number of height here, you multiply with the one is direct proportion. So that's how you get OT, plus minus. Finding the height shouldn't be too bad, right? Because we got the volume is 35 units, cube units of volume. Well, any pyramid is 1/3 base area times height. Base area. So base area is just finding the area of area triangle OSR multiplied by height. Then we have area OSR will just be half OS cross with OR. My goodness. OS cross with OR, we need that. Anyway, we need a normal for OS cross with OR. So I'm gonna just sidetrack here. Side quest. Minus 413 cross with IJK. Cross it out. Cross product. 0 minus 3. 0 minus 15, 15, overall negative, negative 4, negative 1, negative 9. This is normal vector, 1, 0, minus 3. I always double check cross product. I also very scared. Usually I'm quite scared with cross product. Okay, there you go. This is it. So in other words, the normal, which is actually normal of this. Okay, so this case here will just be 1, 6. This one can multiply. Then you just minus 3, 15, 19. H, 35 units here. I think that's pretty okay. This will be 35 times 6. Square root 3 square times 15 plus 9 times 9. 3 square plus 15 square plus 9 square. Height. Key in calculator. Then that will be height. $35. Okay, I'm gonna do this. 35 times 6, which is 210. 315 divided by 25 and see. Okay, no. 36. Divide perfect squares. 9. I think 9 can. 35. Okay, so this is square root 315 is 335. So 9 and 35. 210 divided by 3 would be 70. Okay, there you go. OT is just height times the unit vector. Okay, but plus minus h, because you have these units here, the height here. This is direct proportion. Okay, so this amount of units for every one unit vector of n. So you use n, which is minus 3. So this is a unit vector of n. This is 70 over root 35. I think you will get like this is negative 3. The normal is the same. Negative 3, 15 minus 9. Negative 3, 15 minus 9. Then you just divide by the unit vector, which is 3 square plus 15 square plus 9 square. Okay, then you just multiply them. Hopefully you get answer. Hopefully. 35. 3 square plus 15 square plus 9 square. 315. King calculator, plus minus 2/3. Is that the answer? Moment of truth. Plus minus 2, 10. Minus 6. So that's it. They want the coordinates, is it? Find the possible coordinates. So if you want the coordinates of t, minus 2, 10. These are coordinates. So if they want coordinates, just let it be coordinates.